This section deals with areas of parts of circles. So just a reminder, since we are going to be finding parts of areas of circles, the area formula for a whole circle will be involved. This should look very familiar to you by now. We will use it here in just a second when we are talking about finding the area of a sector. Now we're going to be talking about sectors. In section 10.6 we introduced the idea of arcs. Arcs were just pieces of the circle, specifically the outer edge of the circle. Here I have a few arcs highlighted on this circle. Arcs were simply a small part of the whole circle. Similarly, a sector is a piece of the whole area inside of the circle, kind of like a piece of pie. Here I have a red sector, a blue sector, and an orange sector. Oh, and I suppose 3 small white sectors too. Officially, this is the actual definition, although that doesn't immediately make sense to most people. The most popular way to remember it seems to be that a sector is like a piece of pie. Now clearly we need to call sectors something, so we need to be able to name them. In order to make that work, I need to label the endpoints of our arcs here and also the center of the circle. With these labels in place, I can now name the sectors. The name of the sector is kind of like naming an angle. You start at one edge, go to the center, and then go to the outer edge. So for example, the blue sector would be named sector AOB. The red sector is sector COD, and the orange sector is sector EOF. That's how you label and name sectors. In section 10.6 we talked about arc length. For example, we might want to find out the arc length of this red arc here. How long would it be if I flattened it out? How far would an ant need to walk in order to traverse the red arc? In order to do that calculation, we started with the circumference calculation. That calculation would tell us how far it was in order to go around the whole circle. But we didn't want the whole circle. We only wanted a part of it. We only want a piece of the whole circumference. To do that, we needed the arc's measure. This arc happens to measure 58 degrees. So what we decided to do for arc length was that we would only take 58 degrees out of the whole 360 and multiply that by the circumference. That would get us the right amount to tell us what the length of our arc was. That was the logic for how and why arc length worked. The same kind of logic applies for sectors. For sectors, we aren't talking about the edge anymore. We're talking about the inside. It's a piece of the whole area. Therefore, we start out with a whole area calculation. That calculation would give us the area of the whole circle. But we don't want the area of the whole circle. We only want a piece of it. How much? Exactly the same as the arc length discussion. For this red sector, I only want 58 degrees out of the whole 360. That's the proportion my sector occupies. I multiply that by the whole area, and it will give me my sector area calculation. Same exact logic as the arc length. Make sense? The same logic is used for both arc length and the sector area. They are so similar that the formulas are nearly identical. In fact, they have all the same pieces. The only change is the 1, 2 has switched positions. Now granted, that switching of positions has a pretty big impact, but it is interesting that all the same pieces are there. The trick is not to get them mixed up. That's the most common error here. So how are you going to keep them straight? Arc length is a piece of the outside, a piece of the circumference. So make sure you're using the one that includes the circumference calculation. If you're doing an area of a sector, then you need to be using the formula that incorporates the area calculation in it. You need to be able to differentiate between those two calculations. That's how you have to keep them straight. This section will also have you finding the areas of some odd-shaped pieces. I have shaded in an orange section that you might be asked to find the area of. The region of a circle that looks like the orange shaded region is actually known as a segment of a circle. I'm actually surprised there's a specific name for such a specific shape in a circle, especially since that shape doesn't come up all that often, but it has a name. Most teachers won't care if you know the name of it, but most will ask you to find the areas of them. The general process for finding the area of a segment of a circle is to take the area of the whole sector and subtract out the area of the triangle. That will leave you with just the right amount. As a general hint, anytime you need to find the area of a curved region, the sector area calculation will be involved somehow. That's what you will encounter with this section. As long as you know how the arc length calculation came about, the sector area calculation shouldn't be too bad. It's just a matter of keeping the two calculations straight since their formulas are nearly identical.